Come back out. You need to subscribe. Huh? No. Time for the aimbot. Back again. Better than before. Swedz C#. We are at part 4 of the Counter-Strike 2 external series, and today we will take the final step by creating the infamous Aimbot feature. After this tutorial, you will have the full project in its glory, seeing entities through walls with the ESP, but also instantly aiming at them at the press of a button. I think that this will be the end of this series, because we have the core features, but don't worry about missing certain features like the bone ESP and so on, because I will create another CS2 series, this time using the automatically updated offsets from your local offset dumper. And I need you guys to write down all of the features that should be added in the comments. I will take the suggestions and then use them when I plan the next series. But also, don't forget to subscribe and like the video as well, so you get notified when I do drop the new videos. The Discord server is also available in the description, and the video is to your liking. Now enjoy! Welcome to today's showcase. We're finally at the end of this series. So we have our menu, we have all of the options, we can see people through walls, we have the aimbot feature, so if I hold the aimbot key, he will aim at the nearest enemy, and if I use the closest to crosshair, he will aim on the nearest to crosshair. So before he aimed here, now he aims here. He aims at the enemy closest to the crosshair. Let's take a closer look. So, I hold the aimbot key. He's aiming at closest to crosshair. If I remove the closest to crosshair, he aims at the nearest. So, this is the nearest. I'm aiming at these folks, but he aims at the closest. So, we have our aimbot feature. We have our ESP. We can see through walls. We can but we're done with the series so far, and I hope that you enjoyed this series. Alright, so we're gonna start this tutorial by going into Counter-Strike 2, launching it with -insecure, and I will show you how I get the offsets really quickly. Alright, so we have CS2. Let's add some bots. And stop them. Now that we have the bots, we can search for our character self again. Decrease it by using hurt me. Search for 95. We have 12 results now. Now, one of these addresses hold the health address, and it will point to our player address like we saw in the first tutorial. So I will go from the middle, check what accesses this address, or find out what accesses this address, and look for our 32C, because we knew that that was our health offset from before, as long as the game hasn't updated that. So 70, nothing yet. 8, there wasn't anything else. So from the bottom, the upwards, nothing. 32C. So we found the correct address, and we will take, this is RCX, you can see here. Take that address and search for it like we did the first time. So how long did that take? Now we have two addresses. One of these are the local player, and the other is the entitylist. So Control B, Control D, Control N to open the dissector, and here we see multiple pointers, which means this is our entity list. And the other one will be our local player. Now, you can also see that for the entity list is often lower than the local player in these values. So, but we have our addresses. Let's write them over. That was the entity list. And then we have the local player. You look at that. Now the last address that we will find is the viewmatrix. So let's copy paste our code from earlier and search. Oh wait, I forgot to set the angles. So we set the angles to 89, 49, then search for the byte array again. And there you have it. We have the viewmatrix as well. Now, if this didn't work, you can always watch the full tutorial on getting the viewmatrix in part 3. So, we have updated our offsets. Now, we will also find the view angles of the character. So, let's find these view angles. They will be in degrees. From 90 to -90 up to down, or it's 89, and 180 degrees from left to right to -180. Let's show these angles by using the show position 1. Here we can see the angles. 52 is the first one, -30 the second one. Let's search for the first value. Here, the first angle, which will be 52. We change it a bit, go upwards, now it's 47. .73, I can barely see it. But now we have 940 results. Let's scroll down our address list and only pick the screen addresses that says client.dll. Now, one of these will be correct, so let's test them by freezing a couple of them, like that. Shift, then click to select multiple, space to freeze, then try to move the mouse upwards. Now, it didn't freeze or pull us down, which means these are not the view angles we're searching. Let's try the next view. And it pulls us down. Do you look at that? So, somewhere here, our view angles are laying. So, let's go from the top. Select only 3 now. You can see it still pulls us down, and that means it's only one of these 3. Let's select the first one. Nothing. Second one. Nothing. Something happens, but it's not the view angle. Some sort of camera thing. We freeze the next one, and it locks us in position. So we have the view angle. And since we have 2 view angles, we can access the next one by adding 4 in hex to the address, because in float, or a float is 4 bytes. And oh yeah, I need to freeze it. So we add 4 bytes, then freeze it. This should lock our yaw in position. So if we try to move right and left, it pulls us back. So we have found the view angles. We will take this address as well and write it down as a new offset. View angles, because both are there. They are just 4 bytes or 4 in hex apart. So there we go. We have the new offsets for this tutorial. Alright, back at the desktop, we will open our project and let's minimize some of these functions so we can navigate through this class. Now that we have some order, we will add some new imports. One will be getAsync keyState we will use for our hotkey, and some class variables that are important for the Aimbot. Here we create our hotkey for the Aimbot. It will have the hex value 0x06, which is the exponent 2. You can find out more of these values over at Windows Virtual Keycodes. We will also add an attribute for the entity class, which is the angle difference. This will hold in float the distance between the crosshair and the entity. We will go more in on that later. And we can't forget to add the view angles offset to our offsets class. Don't worry about this view offset. I added that by mistake outside of the recording. Let's also add a boolean to enable the aimbot, because I forgot. For this aimbot, we will have an aimbot method, the main logic of the aimbot. This will check if we're holding the aimbot hotkey and if our aimbot is enabled. If so, we will check that there is an enemy available by using enemy team.count greater than 0. And then, if there is an enemy, we will aim at them. So let's create some methods for aiming at the entity. The first method will be calculating the magnitude between two 3D vectors. We'll calculate this by taking the square root of x squared plus y squared plus z squared. And of course, we will be using delta x, delta y, and delta z instead of the original variables. Delta meaning difference. Now that we can calculate the magnitude from two vectors, let's add it to the update entity method and check with the local player how far from the player the entity really is. While we're here, let's organize this update entity by 3D, then 2D, then 1D attributes, because we need to calculate them in that order. The next method will be the calculate angles method. This method will take in two 3D positions, then calculate from the first position the angles to the next one, the yaw and pitch. To calculate the yaw between position 1 and position 2, we will take the delta x and delta y. Then, using ATAN2, we will calculate the angle. So we create this sort of triangle with the difference between the two positions. So we use delta x as the adjacent side of the triangle and delta y as the opposite. Then we divide the opposite by the adjacent to get the tan. Then use ATAN2 to get the Euler angle. Then we multiply by 180 divided by math.pi to convert it from radians to degrees. Now we will calculate the pitch. Now, instead of having the delta x and delta y, we will use the delta z and the distance from the two entities. So we will create a new line with the hypotenuse with the delta x and delta y, then use the triangles again. So let's get the delta z and distance first. So to get the hypotenuse, we take the square root of a squared plus b squared, and we just replace A with delta y and B by delta x and take the square root. Voila, we have our distance. Now to calculate the pitch, we will take the A tan 2 and use our delta z and distance in our new triangle, then multiply it by 180 and divide it by pi. We will also add the minus at the beginning because the angles were minus when we aimed upwards and positive when we aimed downwards. But now we replace the opposite with the delta z and the adjacent by the distance. We get the tan, and using a tan we get the degrees again. So it's not really complicated. Then we return the new angles. Why I'm using a vector 3 is because, I don't know, the final step before using our aimbot will be to update the game's memory to use our new angles. So we will just use swed.write float 2 times to write the new angles. Also remember that the y-axis was before the yaw. Then to get to the yaw, we added 0x4 in hex to the address. We will go back to our main aimbot method, then create some new angles that are calculated with the local player's origin and the enemy team's origin. We will also use an offset vector, which will just offset the player's z position by 10 units, because otherwise the aimbot will aim a bit too high for our liking. Then we just call our AimAt method with our newly calculated angles. Now before we run this aimbot, we will have to go into the reload entities method and order our entities by the magnitude, or the enemy team rather. And at last we call our aimbot method inside of our main logic method. The aimbot should work now, but let's add the option inside of the menu as well. And now that I'm running CS2 with dash insecure, let's take a look at the aimbot at the moment. There you have it, our aimbot option, and it's selected. Let's hold our aimbot key, and there you have it. We aim at the closest entity to our local player, and we can just click the shoot button and it will aim on the enemy. Now, don't drop out now, because we will also go through how to select the entity that's closest to our crosshair, which is more handy if you ask me at least. So let's go. So to calculate the distance between the crosshair and the entity, we will take the 2D position of the entity and the center of our screen. Then we will use this method right here, calculate pixel distance. We will take the 2 points, then just like before, what we did to get the distance, we will do with these 2D vectors instead. So we get the square root of the delta x and delta y, but now with the pixels. And just like before, we will update the entity and now give it the angle difference, which will be the calculation of the pixel distance. It's not really the angle difference, it's more about pixel difference, but who cares? And now, instead of sorting the enemies by their magnitude, we will now use the pixel distance. So we will have a boolean to check if we want to enable the closest to crosshair. If that's true, we will order the enemy team by their pixel distance. Let's also add it to our menu, and using a an if statement, we can only have it visible when they have enabled the aimbot, because we don't want to enable this if we don't have the general aimbot enabled. Now that we have our boolean, we can finally order the enemies by their pixel distance instead of the magnitude. Alright, so let's take a look at the end results. I run our program, and of course I run Counter-Strike 2 with --insecure, like you should. And now we have one more option. We have closest to crosshair. Now if we try our aimbot here, it will aim on the closest entity. But if we enable this closest to crosshair, it will aim on the entity closest to our crosshair. So when I stand by these characters and aim at this one, I should not aim at this guy if we have this option on. So let's test it. Would you look at that? So using this method, we can more easily aim on the character that we're aiming on, instead of just focusing on the nearest enemy, which is, at least for me, many times more likely. I want to aim on the enemy closest to crosshair. So remember, add in the comments what features you want for the next series, and maybe subscribe, like the video, I don't know. Do what you want to do, I suppose. And I'll see you guys later. Thank you for watching.